Assalamualaikum warahmatullahi ta'ala wabarakatuh. Now we are going to talk about physiology of iron. A proper scientific investigation on iron, which is ferrum, have gained more attention over the last decade due to its reputable industrial revolution, weapons, industrial equipment, oil and gas industries, food industry, and also in development of human body system. Theoretically, the iron has been recognized in human history beginning about 3,200 years ago. It was called Iron Age, which that time is about how humans used iron metal for the first time they had thought. Iron also one of the oldest metals and was first fashioned into useful and ornamental object at least 2,500 years ago. Although iron is a common element, but pure iron is almost never found in nature. Most iron was found in mineral form by the combination of iron with other elements. Pure iron is a soft, grayish-white metal. In other prospect, iron is an element that lightly rusts in moist air and abundant malleable ductile magnetic silver-white metallic. The most use of metal is the vital biological processes as transport oxygen in the body. The physical and chemical properties are characteristic of substance like iron, which distinguishes it from any other substance. Iron also is the most common exists as state of matter, as solid, liquid, gas and plasma. Other than that, iron also has a very high tensile strength. Tensile means it can be braced without breaking and very feasible. Workability of iron is the ability to bend, roll, hammer, cut, shape, form, and otherwise work with a metal to get it into a certain fancy shape or the thickness. Historians trust that about 5 or 6,000 years ago, the first people that have worked out using a small amount quantity of iron, it was during the ancient Egyptians. The metal that they had used was apparently extracted from meteorite. Meteorites are chunks of rock and metal that fall from the sky. Some meteorites are very rich in iron. They are also made tool and jewelry out of iron. Evidence of what was believed is due to history of the ancient Hittite culture, which is now known as Turkey.
Next, we move to iron in human body system. Heme protein is transport oxygen as hemoglobin and myoglobin. Transportation of hemoglobin happen when oxygen is binding instantaneously with iron atom, which is stabilizing in ferrum to oxidation state. Myoglobin authorizes the oxygen move from erythrocytes into mitochondria in muscle cells. Another functions of iron in heme are producing ATP in mitochondrial cytochromes, transferring of electron, and utilizing of oxygen. For non-heme proteins, it is consisting of iron-sulfur complex which are made up of cubical arrangement of 4 atoms of sulfur and 4 atoms of iron. Iron is functioning in enzymes of energy metabolism such in aconitase. Intestinal mucosal cells consisting of iron which is stored in liver and transferred into the blood for transportation to other tissues. Serum protein brings iron 3 which is named transferrin. Transferrin accommodates two sites which are binding with iron 3 strongly. Each of transferrin molecule binds with two ferriions. The transferrin content in serum generally around 1/3 saturated with iron. Absorption of iron happens at the most part of jejunum and duodenum. The duodenum is enrolled by the phenomenal state of iron, which is abundantly affects its absorption. The earliest place of activity for both heme and non-heme iron absorption is uppermost, allocation of the duodenum with its low pH luminal circumstance. Heme iron is absorbed efficiently than non-heme iron. The absorption of heme protein and non-heme protein depending on body iron status and bioavailability from the diet. When our body is consuming lack of iron, it will cause anemia. Anemia is a condition where lack of iron in the body leads to a reduction in the number of red blood cells. Iron is used to produce red blood cells, which help carry and store oxygen in the blood. Iron deficiency anemia caused by bleeding in the stomach and intestines.
Next, we move to the next part, which is uses of iron in food industry. First, iron is used as an additive in animal feeds, for example, dogs and cats. The additive is sourced from mined ore containing siderite. It is produced by drying and grinding the ore. Iron-containing additive is safe when supplied to the feeding staff. In sum, it is proven that iron is good for animals and also safe for them. The research shows that iron can prevent the dogs from getting the disease which called anemia. So it is proven that iron is good for them. Second, iron is also widely used in breakfast cereals. Foods are fortified with iron because it is considered an essential ingredient of the daily diet which must be present for the body to function properly. It is an important source of iron in our diet. In fact, Americans consume an average 23.6 milligrams of iron per day, and interestingly, 53% from them coming from grains and breakfast cereals. It is not hard to get iron nutrition nowadays. These cereals have become very commercial over the world. For example, Cocoa Crunch, Honey Stars, Kellogg's, etc. The cost is low too, and we can get the cereals easily from the store. Thank you.
Application of iron during Asian time. According to the verses, Allah already told us that iron has reliable power, which can be used as materials for war, like sword or knife. Besides, the verse also discuss about iron as the benefits for mankind in this world. We can relate it with the application of iron objects in megalithic communities because most of the artifacts in this society made up from iron. Iron technology of the ancient megalithic communities in India. The megalithic period in India is notable for the emergence and development of iron metallurgy and the appearance of new buildings known as megaliths. They produce and use the plates as and farm implement in their daily life that made up from iron. This shows the apparatus that had been made during that time. We can conclude that iron plays a very significant role during ancient times until now. Iron objects or artifacts from megalithic sites in India have been examined for their microstructure, chemical composition, and age. Microstructure. For the first picture, microstructure consisting of spherical particles of cementite, which is indicating partial spheroidization that was induced by thermomechanical treatments spread out across a black background after examining. For the second picture, it shows the dark background was throughout scattered by particles of non-metallic inclusion because the structure is uniform over the entire cross-section. Next picture consists mostly of ferrite grains that indicate the specimen is made of almost pure iron. Last picture shows the presence of non-metallic inclusion in an or as uniform background. Thus, most specimens from Blake area were found to have much carbon as opposed to the low carbon specimen from East Flank. Processing. Usually, at the time iron objects are produced through the process, including the smelting of raw material from ores, the carbon concentration.
Now move to application of iron in nowadays. The application of iron and silicate materials in inhibition of arsenic accumulation in Japanese rice. There have three types of commercially contained ferromaterials, which is converter furnace slag (FM), ferrum oxide material (FP), and metal ferrum powder (EM). Frames without the application of ferrum materials were used as the control. Therefore, ferrum and silicate material is used by them to reduce the excess arsenic in paddy field. The ability of the application of ferrum and silicate materials to inhibit arsenic from an area surrounding a farmer toward the goal of establishing agronomic methods applicable to common paddy field farming. The uses of iron oxide nanomaterials in wastewater treatment. Nowadays, the wide range of contaminants in surface area and groundwater has spread become a critical issue worldwide. An effort to solve the difficult situation of water pollution, there have some significant progresses and rapid in wastewater treatment. Some of their applications are absorptive technology, immobilization technology, and photocatalytic technology. For absorptive technology, it have two types, which is iron oxide nanomaterials (NMS) as nanosorbent for heavy materials and nanosorbent for organic contaminant as iron oxide nanomaterials. For iron oxide nanomaterials, as nanosorbent is heavy metal. Heavy metal contamination is very dangerous because of its toxic effect on animals and human beings, plants, and its tendency for bioaccumulation. To remove the effective methods for heavy metal ions are iron oxide magnetic nanosorbents. It is because of its capability to solve the problem of large volume wastewater and being suitable for magnetic separation and could illustrate excellent superiority. Then for nanosorbent for organic contaminant as iron oxide nanosorbent, the absorption has been widely applied in separation process to remove chemical pollutant from water. Therefore, iron oxide nanosorbent are being explored as it is an effective and low-cost absorbent for organic contaminants absorption for the efficient treatment of fast separation and large volume via employing a strong external magnetic field. Secondly is photocatalytic technology. It is one of the advanced physicochemical technology applicable in photodegradation of organic pollutants is photocatalysis. Iron oxide nanosorbent is a good photocatalysis in absorbing visible light. It can be attributed to considerable generation of electron mole pairs through the narrow gaps elimination. These nanosorbents are illustrative of a new ways to manipulate the catalytic properties of iron oxide toward an effective and safe wastewater treatment nanotechnology. And lastly is immobilization carriers. Iron oxide nanosorbents have been widely used in immobilization technology, as it is also shown considerable potential in the immobilization of biomass. Due to the advantage of chemical inertness and favorable biocompatibility, the bioabsorption capacity of variety of macro and microbial biomass is used to remove various pollutants.